Hi, ladies and gentlemen. Today we're going to go through our introduction to topographic maps notes. These are located in your digital notebook. Please make sure you're completing these as you view this video. Topographic maps. These are two-dimensional models of the Earth's surface, which represents a 3D world. Topographic maps are also known as contour maps. Now these are going to show elevation above the sea level using what's called a contour line. Now here we can see an example of a mountain, and they put these lines on it that are separated out at even intervals of elevation. Each line represents another 500 feet above sea level. And now these lines are seen as continuous things that follow that height around the entire landmass. From the top, we can see what the topographic map would actually look like, following that one continuous line all the way around at that single elevation for that landmass. And you can use it when you look at the side view or the real world view. You can line it up with the contour map, just like this. So each one of these, the 1,000-foot line lines up with the 1,000-foot line, and so on and so forth. You can do the same thing with your hand. Flatten your hand out, or make that, and when you make the fist or flatten your hand out, you'll see how those contour lines will change. All right. So flatten it out, and that'll be your contour map of your fist. Now, contour lines are lines that connect points that are of the same elevation. They show the exact elevation, the shape of the land, and the steepness of the land slope. Contour lines will never touch or cross. All right, so each one of these lines is a contour line, and they show the changes in elevation. All right, so when contour lines are close together, this indicates that we have a steeper slope. It shows that the slope is changing its elevation very quickly in a very short amount of space. That would give us a very, very steep slope. When they're spaced out, we're going to have a much more gradual change of that slope. So here's something that would be steep. Here's something that would be a little bit more gradual. So here on our contour line, or on our contour map, we can see that the contour lines are very spaced out, versus over here where we have something that's very steep. Again, here's an example of a steep slope. And you can see that in the real world example right here of a very steep ridge where the elevation changes very, very quickly. Over here, they're a lot more spread out, as well as down here. So contour lines, if they're far apart, this indicates the land has that gentle slope. Again, here you go. You can see that gentle, gradual steepness. Just like this field here, gentle, gradual steepness on those contour lines. Contour lines will never cross. This is because the same spot cannot have two separate elevations. And if they're crossing, that indicates that they both have that same elevation, which won't work. So contour lines can never cross. All right. Contour lines form closed loops even if it's not shown on the map. So even if you can't see it on the map, the contour line will form a closed loop eventually. Contour lines bend upstream or uphill when crossing a stream. So if you see a stream and the contour line is bending, that tells you the direction of the stream. So here you can see this stream cutting through right here, and that's a contour, or these are all bending uphill this way. Again, the V points uphill. This is due to the way that the landmass will likely erode when water runs down it. So these are all pointing up the hill. Just again, over here, these point up the hill. So this is our high ground right here. All right. The maximum possible elevation for a hill is one less than the contour, one less than what the next contour line should be. So If our contour lines are spaced out by 10 feet or 10 meters each, and the highest contour line we have is 80, that means the maximum possible elevation for this hill is 89, because if it hit 90, we'd see a separate contour line for 90 right there at the peak. So if this, our contour lines here are 20 meters, so we have 220. This would be 200. Then we have a 220 contour line, which means the peak of this hill can be considered to be 239, because if it were 240, we would see another contour line on there. Same thing here, 300, 320, 340, 360, 380, which means this has to be 399, because if it were 400, we would again see another contour line there. Depressions, contour lines which show a depression, crater, or sinkhole on a map. Now, these are going to have these little dashed lines on them, and they will point into our depression. Map scales. This indicates the distance on the map compared to the real world distance. This is going to be this is going to be graphically shown by a line that's going to be divided into equal parts and marked in units of length. This is an example of a scale you could see on a map. It has it broken down so that you can more accurately measure distances on that map. Now, it'll also have a ratio here that shows how big or how small or big the map is compared to the real world equivalent of that area. When you go to read a contour map, make sure you first determine the contour interval, so the space or the height elevation that separates each contour line. When you do this, then determine the map scale, usually at the bottom of the map. Identify any hills or depressions, and then use the legend to identify man-made features such as roads or bridges, stuff like that might be seen on the map. So when we go to look at these contour maps, make sure you look for areas where the contour lines are close together. That's going to indicate steeper slopes, and then when they're spread further apart, those indicate more gentle slopes. Now, guys, if we're going, again, take a look at what this is going to be like in the real world, here we have our person, our little explorer here, walking up a hill. As they walk up the hill, they're going to mark these different elevations. So we have 100 meters, 200 meters, 300 meters, and then they're at the peak. Now, if we were to do contour lines for every 50 meters, we can see that the peak right here gets up to 350, but we know it's going to be less than 400. Now, this is what that contour map would actually look like here if we actually looked at it from top down rather than the side. And again, our guy just travels right on along. All right, ladies and gentlemen, we're going to stop there. That concludes our notes here for today. If you have any questions, make sure you reach out to me. Otherwise, I hope you guys have a great day.